Alright, so today we're going to look at the law of cosines. The law of cosines is used when we have an SAS triangle or an SSS triangle. So if we had side angle side or side side side, that's the indicator that we're going to use law of cosines. Now, law of cosines has three different equations, but they're all handled the same way. It just depends on what information it gives us. If we look at the first equation, just to kind of show you on this triangle what's going on, we're going to try and find side A, given that we know B, C, and angle A. Alright, so that's SAS, right? Now, we can also use this when we have the three sides. So let's say we had side A, B, and C. That'd be SSS, right? We can use it to find whatever angle measure it asks us to find. We would just have to end up doing some algebra and then the inverse of cosine to get the angle measure to solve for that. So let's look at an example. First, we're going to start with looking at SAS. So set up your triangle first. Alright, so we have A, B, and C. So it tells us side A is 12, side B is 18, and angle C is 44 degrees. So we have SAS. Alright, so SAS, we're going to use law of cosines, and it's asking us to find the missing side. So the missing side would be C. So I want to use the formula that's C squared equals. So that would be this. C squared equals A squared plus B squared minus 2AB cosine of 44 degrees. So after we plug in everything, it would look like this. 12 squared plus 18 squared minus 2 times 12 times 18 cosine of 44 degrees. So you can type this into your calculator all in one step if you would like. I like to break it down into a couple steps just so I don't accidentally type something wrong into the calculator. So 12 squared would be 144. 18 squared would be 324. And then negative 2 times 12 times 18 would be minus 432 cosine of 44 degrees. So adding up these things here, 144 and 324, and then subtracting 432 times cosine of 44 leaves me with 157.245. Now to get C by itself, I'm going to square root both sides. So we get C equaling approximately 12.5 after rounding. Alright. So if you want to try B on your own, go ahead and pause the video and try it. It's set up the same way. So let's go ahead and solve this. First, we're going to set up our triangle. Now, I noticed that A is 120 degrees. Now, this isn't super important, but I know that that is an obtuse angle. So when I go to set up my triangle, I'm just going to make it look a little bit different here. So A, B, C. Again, you don't have to do this. You're not going to be graded on that or anything like that. So A is 120. Side B is 30. Side C is 24. So this time, we're solving for side A. So I want to pick the formula that starts with A squared equals. So B squared plus C squared minus 2BC cosine of A. Plugging everything in, A squared equals 30 squared plus 24 squared minus 2 times 30 times 24 cosine of 120. Doing a little bit of calculating in the calculator here. We have 900 plus 576 minus 1440 cosine of 120 degrees. So adding these guys up and doing our subtracting there, we get a squared equals 2,196. Square root both sides to get a by itself, and we get a equaling approximately 46.9. Alright, so that's using the law of cosines when we have an SAS triangle. Now let's look at a word problem that'll go with this. So we have a triangular lot. It gives us two side measures. Okay, so we have 84 feet and 78 feet. And it tells me that the angle between the two sides is 102 degrees. So I always like to use, in this instance, I would make this my angle A. You don't have to do that, of course, right? Any way you set up your triangle, as long as it's SAS, meaning that the angles in between the two sides, you'll get the same answer. It's just your variables might be a little different than mine. So setting up my triangle here, we have 102 degrees BC. So I'm going to make side C 84 and side B 78. Again, it doesn't matter if you had it the other way around, you would get to the same answer using the law of sines. So this is an SAS triangle. Okay, and it's very important that when you set up your triangle that you set it up correctly so that it is an SAS triangle. And the way we can tell that is by reading the sentence here, and it tells me that the angle between the two sides, okay, so that means that it's the angle that's going to be made from those two sides meeting, which would be this right here. Alright, so I'm trying to find side A. So I'm using the formula a squared b squared plus c squared minus 2bc cosine of a. Plugging in everything I know, we would have 78 squared plus 84 squared, 2 times 78 times 84, cosine of 102 degrees. So 78 squared is 7,056. 84 squared is 6,084. 2 times 78 times 84 is negative 13,104 times the cosine of 102 degrees. Adding up everything and subtracting, we get a squared equaling 15,864.5. Now I need to square root both sides. So a is approximately 126 feet. Now that's not my final answer. When you read the sentence here, or a question, it asks for the total amount of fencing, not just side A's amount of fencing. So we have to add up all the different side lengths. So my total is going to be 126 feet plus 84 feet plus 78 feet. So the total amount of fencing I would need is 288 feet. Alright, now we're going to look at, given three sides, we're going to find the specified angle. So, setting up the triangle real quick, we have A, B, C. Side A is 32, B is 20, and C is 40. And it's asking us, let's find angle B. So I want to use the formula that has cosine of B attached to it. So that's the one that starts with B squared. A squared plus C squared 2AC cosine of B. Plugging in everything. 20 squared equals 32 squared plus 40 squared minus 2 times 32 times 40 cosine of B. So I don't know the angle measure this time, so I'm just going to leave it as B. Doing all my squaring and multiplying, we would have 400 equals, I'm going to do 32 squared plus 40 squared all in one step. So that would be 2,624 doing my multiplying, I get 2560 cosine of b. So I'm going to subtract first the 2624 to the other side. So that would leave me with negative 2224, negative 2560 cosine of b. Now, to get cosine by itself, I'm going to divide that number in front to the other side. So we would have the cosine of b equaling, typing that in the calculator, that does simplify if you want to, just to make the fraction a little bit easier to write. It's 139 over 160. Now, to find what angle B is, I'm going to have to use the calculator, and I'm going to have to make use of my inverse trig. So, angle B equals the inverse of cosine, 139 over 160. Typing that into your calculator, you would get that angle B is approximately 29.7 degrees. So SSS, which is what this triangle is, right? I know the three sides. Little bit more work, right? You have to do a little bit more subtracting and dividing and all that stuff, and then we have to make use of our inverse trig. So example B, same type of problem. So if you want to try it on your own first, go for it. Go ahead and pause the video. If not, here we go. So set up the triangle. Side A is 60, side B is 88, and side C is 120. And we're trying to find angle C. So that means I need to use this formula. Plug in everything I know. So 120 squared equals 60 squared plus 88 squared. 2 times 60 times 88 cosine C. So same thing as before. Let's do our squaring and multiplying and adding and all that stuff. So 120 squared, 14400, 60 squared plus 88 squared would be 11,344. Alright, so doing all my multiplying, that gives me 10,560. So subtract. Leaves me with 3,056. And then divide. So we have cosine of C equaling negative 191 over 660. Again, I like to simplify the fraction just to make it easier to write, but again, you don't have to do that. So again, I need to get C by itself. So in order to do that, I'm going to have to use my calculator, and I would type in cosine inverse, that's negative 1, of negative 191 over 660, and that would give me an angle measure of 106.8 degrees. So that is the law of cosines. Now let's just look at a little refresher here. So when to use law of sines, when to use law of cosines. We mentioned that way back in the second video when we started doing law of sines, but just to refresh our memory, we use law of sines if we have an AAS triangle, an ASA triangle, or an SSA triangle. And as we just saw, we use law of cosines when we have SAS or SSS. So it's not always going to be broken down into its particular sections. A lot of times you're going to have to read through the problem, set up your triangle, and then identify what type of triangle you have, and then figure out, well, which law am I using, law of sines or law of cosines. So if we look at our first example here, if this would scroll down, here we go. It says, 2 ships have arrived to help an immobile submarine. So if I look at my picture, it's already drawn for me. Here are my 2 ships. So this will be A, B, C. So my two ships are A and C. B is my submarine. Alright. So it says they determine the distance to the submarine and the distance between each other, as in the figure below. What is the depth of the submarine? So we're trying to find this height of the triangle. So because it's a y distance, I'm going to say that this is y. If you wanted to use x or h for height, you could do so. So looking at my triangle setup, I have the three side lengths. So this is an SSS triangle. Alright, so that means I'm using the law of cosines. And I'm going to use the law of cosines to figure out one of the angles inside. Now, once I have one of the angles inside, I can use that information to figure out the side length of y for this little right triangle. And I'm going to use this side. You don't have to use that one. You could have used the other side and found angle C if you want it. The only one that isn't really helpful is finding angle B, because that's split, and we don't know how it's split. So I'm going to find angle A. So I'm going to use this formula, a squared equals b squared minus c squared, or plus c squared, minus 2bc cosine A. Plugging in everything. So here is A, here is B, and here is, here is C, and here is B. So A is 499 squared, 615 squared, plus 629 squared, minus 2, 615, 629, cosine of A. So 499 squared is 249001. Squaring and adding those, we get 773866. Doing my multiplying here, I get 773670 cosine of A. So we're going to subtract. And that would leave us with negative 524865. And divide to get cosine by itself. So cosine of A, simplifying that fraction a little bit, we get 34991 over 51578. Again, calculator, inverse trig. Angle A is cosine inverse of 34991 51578. Type that in, hit enter, and we get an angle measure that is 47.3 degrees. Alright, now that I have that information, again, I'm going to use some of my right triangle trig. And I have angle A. The side length I'm trying to find is opposite side, so I want to make use of sine. Remember, sine is opposite over hypotenuse. Here is my hypotenuse. So sine of 47.3 degrees, y over 629. Multiply that over. So y would equal 629 sine of 47.3 degrees. So our submarine would be 462.3 feet deep. Alright. Now, let's look at the next problem here. So, two people are looking at a kite 30 feet from each other and observe the kite at angle 62 degrees and 78 degrees as shown below. How high is the kite? So, when I draw the height from the kite to the ground, it's going to form another triangle. So here is my height. Again, y distance, so I'm going to label that y. Now, if I think about how I can find that side length, this now makes one big right triangle. Okay. So eventually, we're going to do some right triangle trig like we just did in the previous problem, right? Opposite over hypotenuse or adjacent over hypotenuse, however it's set up. But in order to do that, we need to find some side lengths here. So, looking at my little triangles, and I'm sorry, I drew this wrong. Eraser's not working. Sorry. Do it that way. Okay. So, I need to find this hypotenuse length, which would be this right here. Okay, so here, we're going to make use of this right triangle. Okay. So, I have this total angle here would be 180 degrees. So if I subtract what's given, that would leave me with 102 degrees. Right, so here would be 102 degrees. So then I know that this angle is 16. So I'm going to use the law of sines on this outside triangle to find the hypotenuse of the right triangle. Kind of confusing. So here is what I'm going to make use of, and I know that I have the sine of 16 in this 30 feet. So that'll be the ratio I know for law of sines. So this would be, if I look at this bottom of the left triangle, that would give me SAS. Or sorry, gosh, ASA. Right? Angle, side, angle. Alright, so that means I'm using law of sines. So setting up the ratio, I know. I have the 16 degrees from the top and the 30 feet from the bottom. So the sine of 16 degrees over 30 feet. And I want to find h, right, the hypotenuse of the right triangle. So that would be the sine of 62 degrees all over h. Do some cross multiplying. Divide. So h would equal 96.1 feet. Alright. Now, looking at the right triangle, that I have 78 here, and I want to find the y length there, the height. So I would have to make use of sine again. So again, we're going to make use of some right triangle trig. Just going to scroll down. So the sine of 78 degrees equals y over hypotenuse, which we just found was 96.1 feet. Multiplying that over, we have y equals 96.1 sine of 78 degrees. So our kite is 94 feet high. Alright, and that's it.